Thank you. Thanks for joining. So let's start by quoting the classics.
Oh, hello. Yes. Can I read it? See the tremendous or does it set patterns or parts. That's good. The essence of chaos.
Still not in chaos.
Oh, it's simply deals with predictability in complex systems. The shorthand is the butterfly effect. A butterfly can flap its wings in Peking, and in Central Park you get rain instead of sunshine. And then I go too fast. I did a flyby. No, give me that big glass of water. We're going to conduct an experiment. It should be still. The car's bouncing up and down, but that's okay. It's just an example. Now, then put your hand flat like a hieroglyphic. That's it. Now, let's say a drop of water falls in your hand. Which way is the drop going to roll off? Of which finger or the thumb or the other?
Thumb. It's a...
Okay. Okay, now freeze your hand. Don't move. I'm going to do the same thing. Start with the same place again. Which way is going to roll off?
Let's say same way.
Set back to where? Change. Why? Because tiny variations, the orientation of the hairs on your hands.
Yeah, look at this.
The amount of blood distending your vessels, imperfections in the skin.
What imperfections there, skin?
Microscopic. And never repeat and vastly affect the outcome. That's
unpredictability.
Right? There. Look at this. See? I'm right again. Nobody could have predicted that Dr. Grant would suddenly jump out of a moving vehicle.
Alan?
There's another example. See, here I'm now by myself talking to myself. That's chaos theory.
I hope you like it. I think it introduced very well the concept of chaos, no? As Dr. Malcolm says, no? The unpredictability of complex systems. So welcome to this talk about resilience and chaos engineering, friends or foes. I'm Jorge Hidalgo from Accenture Spain. I'm a director in software engineering, and I have the honor to lead our global Java practice and our DevOps practice in Iberia. And I'm going to introduce you a bit about this thing, what's resilience engineering and what is chaos engineering. So let's start with the good guy, right? So resilience is the good guy, right? So resilience is about designing our systems, prepare them, so they are able to really tackle with these unexpected things in a complex system. We want to do early identification of problems, and ideally, we want to have a system that is capable of reacting to things, self-heal, self-operate. So how do we build that resilience? Probably John Hammond will just say, spare no expense. No? So we have all the money in the world to build that resilience, just put more resources, but it's not as simple as that. Obviously, we are not as wealthy as John Hammond, and we don't have infinite resources. So this means that we need to really think on design. This is the starting point. Design for observability, design for robustness, and design for availability. Kind of obvious, right? But why? We want to design for observability because we know that a number of the problems that we have, they will be solved easily if we could just look at them before they are actually an outage to our customers. Identify something that is going wrong, fix it, nobody notices it. So first, designing our solutions for observability is key for anything that comes after. If we don't have observability, we really don't know anything. We are just blind. So this means that we will probably find that there is something wrong when a customer calls, this is not working. Second is design for robustness. we need to think that every single component in our system, no matter how small, should be capable of react to erroneous conditions, handle well internal failure. It could be as simple as component A calling component B, making the call, waiting for some time, no response comes. What I do? I just fail miserably. Maybe I retry. So thinking on this design of every single component and then layer after layer of our system is important for robustness. And of course, for availability. Because we know that no matter how hard we try, no matter how good our design is, we are going to fail at some point. So we need also to have strategies for dealing with the problems. It could be redundancy or many others. We are going to see a bit more in detail. So how do we plan this design for robustness, this design for availability? It depends. It depends on the type of problems that we may have. We may have just a fault, something that is probably going to be undetected if we can just manage to solve it very fast. A small thing. It could be just a small connection problem that just simply goes away. We don't do anything. We just see the logs. There was a problem. Nobody shouted. That's okay. No error budget is consumed. What are the kind of things that we can do to design in our system for these kind of small problems, like a network problem? It could be as simple as retry. Wait for a few seconds. If you don't get any response, just retry. Simple. What happens if we have something more serious, like an error, something that is impacting many users and probably for a longer period of time? Now the problem starts to get a bit more serious. If I don't fix it, probably I am going to have problems with my error budget and with my SLOs and SLAs. So we need to think more carefully about this. If this problem is impacting more users, think about retry, for example. Is retry a good pattern for this kind of situation? I'm going to ask this differently. Who knew about this problem that we have like a few weeks ago with Twitter going down because the front-end app was retrying and retrying and retrying? Thousands of millions of users retrying and retrying. They don't have any kind of circuit breaker to prevent that. There was a problem in the backend. Allegedly, they were not paying for the servers. Who knows what's happened? The problem is that the backend was not able to cope with the demand. The client was just retrying and retrying and retrying again and collapsing the system even more. So retry is not always the answer. In this case, for example, a circuit breaker could have been better. If there is a collective problem of many clients calling B, close that circuit. Sorry, open the circuit. No? Let's not accept any more requests. Give this component some time to recover by itself. And in the meantime, degrade gracefully, not just be pulling out 500 errors to the client. So circuit breakers are very, very good strategies for errors, bulkheads, and many others. But what happens if we have something even more serious? We have tried to design this hard, but we have a really, really big problem. This is impacting most, if not all, of our users. It's impacting most, if not all, of our system capabilities. This is going to consume all of our error budget if we don't act fast. So, for example, for this kind of situation, one very good resilient pattern is the redundancy. We have our production system, and then we have a backup environment, which is probably dormant there. But we know that in the case of the worst scenario, we lost our system, we can just very quickly get the latest data, even a backup or just the glyph data, spawn this dormant system, and have our users not lose too much time. No, maybe we can survive for 1 hour. But depending on the type of error we want to deal with, of the type of problem we want to deal with, we have different strategies for building up resilience. You can see we are computer scientists, engineers, so restart in all of them. No, 90% of our problems just solved by restarting. So we smile and but at the end of the day, don't just discard it. So restarting, sometimes you need to restart and you need to have a strategy for restart. So some very high level overview of resilience. But you know what? We have really spent a lot of time, big architecture team, lots of cutting-edge engineers. We have a very good resilience strategy. We go to production. We are very proud. But still, we are going to have problems. And I'm very sure that we are going to have problems that we never thought about before. And that's where it comes chaos engineering. Chaos engineering is about planning an experiment on our system, which is going to reveal a weakness before it actually happens. The worst thing that we may have is that we found a significant flaw in our design where it fails in production. And remember Dr. Malcolm, complex systems are unpredictable. Many variables, many different pieces. Could be a disk failing. It could be a network cable. It could be whatever thing. It could be software, of course. So how are we really ready for that? Through chaos engineering and experiments. So what's an experiment then? An experiment is the minimum thing that we can imagine in our system that will or probably may go wrong. And then we say, plan an hypothesis for that. What can we learn from this? You're going to see clearly with examples. We plan this, we imagine this hypothesis, and then we set a metric. This is very important, observability. Remember, design for observability. How will I know that the experiment went well? And how do I know that this is getting out of hands and I need to abort the experiment? This is a bit complex, but you need to imagine that the first people that did this, like Netflix, etc., they did this in production. Okay, so they needed to have this, as they say, contain the blast radius of the experiment. We are literally setting a bomb in our production system. We need to be sure that if something goes wrong and this gets out of control, we can abort, kind of the big red button, and abort the experiment. But this is important. Observability should be in place. If not, what I'm doing, I just launch something. I don't know if it is going well or not. So contain the blast radius. Then we run the experiment. Two things can happen. I found a problem. This is perfect. We don't need to be bad for having the experiment because this means that now we can fix a flaw in our design and live happier. So you fix that and you plan the next experiment. If you execute the experiment and see that nothing happens, it went well, then you can go for something bolder, so to speak. So what means this bolder thing? So let's see this imaginary pyramid. We have at the bottom the nouns, things that we know, things that we understand, things that we're aware of. So that's the best way to start. For example, we know that in our Kubernetes cluster, if I kill a pod, another pod will be scheduled to replace the failing one. I know that, and I understand perfectly how this works. So that's kind of the first experiment that I will do. We are going to see this later in the demo, no? It's where we all start. There is something that we know, there is something that we understand. We are going to demonstrate that it happens as it is. But then we can go into more complex things, like, for example, things that we are aware of but don't understand. For example, we may know that if I have a problem in one of the nodes in my complex distributed system, the cloud provider is going to provide a new node for me, another virtual machine is going to make it in the cluster, and then the load is going to be distributed magically, so Kubernetes magics, and everything maybe in 5-10 minutes is going to be normal again. But is it fast enough? Am I going to impact my customers? Should I have more nodes idle just to deal with a problem with one of them? Is it the same if this happens in the morning, in the afternoon, or in peak time? So things that we are aware of, but we really don't understand perfectly how this happened. So this is the new category of experiments that we need to think about, but always after we have mastered the basics. And then, of course, we have things that we don't understand or things that we even don't know, which are the more complex experimental thing. So you start from the beginning, but also Dr. Malcolm will warn us that we were so preoccupied with something that we could do that we were not considering whether we should, okay? He was speaking about dinosaurs, but this also happens perfectly to cause experiments, no? So, translating from Dr. Malcolm to software engineering, he means, never test a known broken system. If your system already has problems and you know about that, chaos experiment is not the answer. So first rule of thumb, never plan an experiment, never test chaos on a known broken system. First, you need to go to design again, replan what you are doing in terms of resilience, and then if you are content with what you've done, then you go into planning a chaos experiment. Start with measuring things that you know, like killing pods, establishing latency in my HTTP connection. That are very simple, nice tools for doing this kind of thing. So start with the small and then go with the more complex things. And another important thing is that, and I will emphasize that, I said it before, I'm going to repeat it, it's very important, always have the means to stop your experiment if it gets out of control. Even if you are not doing in production, you cannot really predict, this is great thing, you cannot really predict what happens. So it's better to always have things in control and plan for it. Okay. I already shared some of these examples. And as I want to save time enough, so you see this in action with the an actual example, I just wanted to pass through this. But you can see, simple one, kill pods, see what happens, take the time. Next step, test in different moments of the day, test with different loads. For example, you plan the experiment at the first time in the morning with very low users count, and everything goes perfect. You do that in a peak moment, and your resilient design is not enough. So that could be the next step. But for example, there is another interesting experiment that you could check. What happens if I shut down 2 nodes, not 1, 2? Yes, it's going to recover, but what's happened? It's going to be fast enough? What's happening with the application in the meantime? So this is the kind of experiment that you can plan and do it growing in complex. So how do you do this? So tools for doing chaos engineering, of course, you can just create your own shell scripts and do whatever you like. But there are very nice tools already in the market that allows you to do and plan carefully, execute, schedule chaos experiment. So Gremlin is one that's very popular. Litmus Chaos is also another very known and popular. It's also open source, so you can try right now if you want. The next one is great, my favorite. There are also the fun side of chaos engineering, and you have tools like KubeDoom. You install KubeDoom in your cluster, then you connect to the pod with BNC server, and then you can play Doom. And when you kill a moth, you're killing a pod. Another very nice is cheesy monkey, which literally you have a monkey in the screen like a Mario game. Every box is a pod. So when you kick a pod, you kill it in the real system. So this is kind of the fun side of them, okay? Not the kind of serious experiments that we are going to propose to our clients, okay? For sure. I am not recommending nor condoning the use of these tools in real world, but they are fun, okay? They are fun. So, friends or foes, okay? I think that is clear to this, that there are no good guys, bad guys. Both of them work together. Actually, most of the time, this is just the SRE perspective of we are just the same team. Sometimes we focus on resilience, sometimes we focus on chaos, while resilience tries to deal with the problems and make our system capable of recovering. Chaos is trying to discover the flaws that our design has. So obviously, the closer that both functions are, the better. So, of course, friends, and that's the point of it, no? So friends or foes, not really. They work together for creating better systems. So I want to save these last few minutes for a real demo, okay? Because this is the moment in which John Hammond thinks that they have everything under control. They put the scientifics in the cars and everything starts to go to hell. If you are not seeing, watch Jurassic Park, I highly recommend it. It's one of the best movies in history. So let's go now. I need to stop presentation. So this is Litmus Cache. Okay, so I have it deployed here in a cluster. It's simple Kubernetes cluster. And the trick of it, we have here 3 nodes. There's not very complex one, but for demo purposes is more than okay. And we have here deployed different applications. I have one specifically, which is just a boring app that I'm going to encourage you to use right now. So if you wish, you can just get to a browser, to your mobile phones, and go to this IP address. Can you see it? 37.59.31.93. It's very, very simple application. You can just say, hello room, and all the messages that put in there are going to just appear in the application. Is anybody going to try? Because we want to run a chaos experiment on this app, and we want to see if you see any problem. I mean, I need your feedback to test the design of my application, okay? So let's see if there is anyone. Okay, I can see one. More than one, I can see. Second, okay. A good activity there. So now we have this simple application. We can see the cluster. We have a couple of nodes here. And what I'm going to do is to go to chaos, to Litmus Chaos 2. This is very nice because I can create scenarios with different kind of probes, different kind of tests, like CPU tests, like killing pod tests, so a wide range of different kind of scenarios I can plan. And for each of these scenarios, I have runs. And for each run, I have my target. And the tool is helping me to collect the data to determine the experiment went well or not. So let's go one of these scenarios. For example, give this guest application. We're going to get the front-end app, and we are going to run the experiment. I'm going to switch to OpenLens. Okay, so I encourage you to continue using the app. Just let's see what's your feeling out of it. What we are seeing in approximately 1 minute is that we have the experiment run. Right now, I'm going to put this at the top. Right now, Litmus Chaos has a small agent in the cluster and is installing all the, let's say, scripting for my experiment, like another pod in the system. And in a few seconds, this pod will get live and will start to run the experiment. In this case, the experiment is every 15, 20 seconds, kill one pod of this application. So at the top, we are going to see how pods come and go. If I can go to this replica set, now we can see that there are 2 pods running for this application. And now we can see that we have the pod delete daemon starting. So if you're looking at that, you will see that there, for example, one terminating right now. So it has started to kill pods. And Kubernetes is behaving as we predicted. We have set replica set of 2. If you kill one, Kubernetes will provide the second that is missing. And we can see this in this log. Okay, so we can see that it's working as expected. In the meantime, what's your experience? Has anybody found a problem submitting a comment? Or everything keeps working well? No issues so far? And that's why it can be. What we are uncovering here is our solution really persistent, the messages? Or are they just floating there in my web application and really, when I start killing the web application, I start missing things, no? So what we are really seeing here and uncovering is that the platform is working well, but the application is probably not so well designed. Because if I kill one pod and I lose part of the information that was in that pod running, let's say I'm not persisting the messages, I'm not really doing a good job, okay? But in terms of the platform, it goes okay. We get some results. Now we can go back to the application. We can fix it and make it better. The tool is not only useful for planning the experiments and running it. You can get all the different analytics for the experiments that you have. So if we came here to, for example, this front-end experiment, we can get how many times we are running it, whether it went well or not, what the statistic of this. I run this experiment just at this moment, no? But I could be planning these experiments on, for example, every day or twice a day in a pre-production environment, just as a matter of ensuring that if I make a change, I'm not only doing my unit test, my integration test, my performance test, I also have my chaos test running periodically in the system, uncovering problems, as we said before, even much before that they can be really a production problem. Let's run a different experiment this time. So in this case, we are going to get a different application, which I'm going to filter here. This is a simple hello world, okay? We have 4 pods for this application. And now let's come here, case scenarios, and say experiment, delete pod, run. This experiment that we have here is similar to the another one, but we are seeing a bit more on the activity, okay? So now we have running 4, and we have here the 4 pods that we have for this deployment. Okay, let's give it a minute. While this is running, do we have any questions? No? Feel free to ask questions. We are going to have a couple of minutes while the Okay, so the question is if...
Could you please just...
I will repeat the question.
Okay.
The question is if we can combine a chaos experiment test with end-to-end test, like simulating of course you can. It's something that also gives you this perspective. I mean, now I am fortunate that I have a lot of testers here that are for free testing application, but sometimes you don't have them and you can afford them. So it's good because you not only test the, let's say, platform side of the story, but you can also test the application side under these difficult conditions, okay? Okay, now we can see the, have you seen it? Like the GLO, something goes wrong, it is terminated and a new one comes. It's so fast that sometimes you just miss them. But have you seen them? I can rerun the experiment if you like. No? I was not distracting you on purpose. It's happening. Okay, well, you can see here clearly. Look at the age of the pods. This has like less than a minute ago. This one, no, because I have, this scenario is just killing 3 pods. We have 4. So this means that if we are doing this random, at least one should survive the experiment, okay? And well, even if you didn't get the moment in which the new pod entered and the old pod terminated, you can see by the age of them that they are really new pods in the application, okay? And again, we can come here to the analytics, check this experiment delete pods, so we can see how many times we've run it, and we can get the different results that we are getting out of the experiment. Okay? So, almost out of time. So, as a summary, let's say 4 or 5 important things. First, resilience and chaos work together. 1, to make the best design possible for our solution. Think about can go wrong and try to provide the means for recovering from the problem. Or in the case that there is a big enough problem, we have redundancy in place to survive this moment. Chaos, on the other hand, is going to be used to discover these flaws in our design before they are actually a problem in production. Third thing, very important, never test a broken system. Remember Dr. Malcolm, always. Never test a broken system. And 4, when you are planning for an experiment, always have 2 things very, very clear. 1, what is the objective? How do we know that the experiment went well? Second, how do I know that something is getting out of control and I need to abort the experiment? Especially if you are not using one of these kind of useful tools that has many of these things already prepared for you. And especially if you are running this in production, okay? And with that, yes, close. I would love to hear more questions, okay? So I don't want to be like Dr. Malcolm speaking here by myself, okay?
Can I invite you down here? We have one question, Slido. Could you recommend some resources to learn more about this topic?
Okay, so in general, there are many interesting works from some of the companies that has been pioneering this. So, for example, Google in their SAD, let's say, place, okay, they have different books, etc. So they have interesting things about designing for resilience patterns, and how to apply them in our system. The people from Gremlin, okay, this very popular chaos engineering tool, they also have a lot of resources in their web. Even very useful readings about the origins of chaos engineering, how this works in Netflix with the Chaos Monkey and Simian Army. You've probably heard of them, no? Those are like kind of the pioneering tools in chaos engineering. So those 2 are usually the 2 good places to start. Okay, yes, I love Jurassic Park movies. Okay, 1 is perfect, 2nd is almost perfect. 3 is not as good, but you didn't ask about Jurassic World movies, well done. But yes, I don't like them as well. Okay, it is generally best practice to do this in production since test is never 100%. Okay, so as I was explaining when we were speaking about the noun unknowns, we may know that something should behave generally in a way, but really, and this is again, the unpredictability on a complex system, you cannot really know 100% just for running one experiment. So that's why when you have already built your first experiment with known nouns, you do the next step, which is I run the experiment multiple times with multiple workloads on multiple different times a day. I measure the mean time to recover in each case. What's the mean time to discover everything that I need to understand? Is this consistently being fixed? Or I have a problem if this happens, for example, at my peak time. So the way of knowing or trying to know if this is something that happens 100% of the time, so it's a known, is to plan and run the experiments many times in different, let's say, scenarios as various or as diverse as possible. Okay? Is there chaos engineering for serverless with no containers? No, that I know of. And this is one of the points, is that you are serverless. You don't have, there are servers, of course, but you don't see them, you don't manage them, you don't have any control of them. You need to, you trust in the provider of the serverless platform for running the workload. I guess that they are doing the chaos engineering on their side, but you cannot do it on your side. Okay? At least that I know of. Okay. Should the chaos engineering be part of the DR drill? Yes, it should. In the sense that DR is one of these redundancy strategies that we have. So how do we test that resilience is okay? Or how do we test that our DR scenario is okay? We have a procedure, this is how we do it. But now we need to provoke it. We are not doing the DR when we need it. Or we should not do a synthetic DR always the same. Because it's always the same, it's always going to be predictably successful. And then you have the real problem, and nobody was ready for that. So DR and chaos engineering goes well together, especially for the most severe type of problems. Okay? I remember this story. We found out in one of my clients that we were able to recover from a full node drain in the cluster in less than 4 minutes the hard way. Someone unexpectedly deleted all nodes of the cluster. Then we found out that it was bad. This came to the feeling that this is the kind of experiment that we should have run before. Now we know, but we know the hard way. Okay? So it's much better if I plan and execute the experiment, and then I say, okay, my DR is in place. Or another case that we have also, which we were using Velero to back up our systems, which is kind of very commonly used too. And then we found out, the moment that we did the DR, that we couldn't apply the latest backups because of attack stuff. So Velero was applying some tags, and when you try to recover the cluster in the different, in the DR zone, the tags didn't match, and the tool went mad, and you need to deal manually with the backups, etc. So that experiment was very useful because we learned that tagging was not okay out of the box. We fixed the tagging, and the next time the DR went, okay, the backup volumes could be attached to both the production cluster and the backup cluster. Okay, is there recommended blast radius, or should we scale until we break something? If you are purist, you should start small and don't stop until you break something. This is kind of the purest way of looking at chaos engineering. If you don't unleash chaos, you are not doing it well. Now it depends on how brave you are and how confident you are with your design. But there is no rule of thumb. Every team and every organization should go to their own pace, because at the end of the day, this is serious business. You can, without willing to do, you can really break things. So it's better to go small, step by step. Okay, are chaos testing used during development phase? Well, it depends. If you think on development like I'm creating my services, my screens, my applications, probably it's not that worth. But you think on developing the platform where you are putting your applications into, then it makes all the sense. Because design, chaos, with introducing before, they should be hand by hand. So if we think on the development of our platform, when we are putting applications, yes, definitely. How do you test a platform? Okay, I can answer this question with a question, which is, how do you test a platform? At least in my case, I don't know any other reliable way of testing a platform, which is breaking things on purpose and see what's happened. It could be the equivalent of running your Selenium or Cypress test in a web application. Okay? How many organizations actually use chaos engineering? Is it difficult to persuade them? I don't know how many. From experience, very few. Okay? It is difficult to persuade? Yes, it is. But usually it goes hand in hand with the confidence they have in the system. So at least it's always worth the effort to put it in place, because if you plan about chaos engineering and they say, no, we are not ready for that. Okay, that's good. Now let's speak about resilience engineering. Why do you are not trusting the design of your platform? So this really means that they are probably not mature enough, not confident enough. We need to go back to resilience, review the designs, probably fix things, and remember, never test a non-broken system. Okay? But it's difficult. I mean, this is why chaos engineering is kind of the nirvana of SRE, or SRE. Only few organizations doing it. Is flooding an API with nonsense also chaos engineering? Yes. Introduce latency.
I just stop you because time's up. So
Time's is up. Okay.
Sorry for that. Just
I'm happy to take any more questions outside of the room. Okay. So no problem with that. But I'm really happy that you have been flooding me with questions. The back pressure has been okay. The circuit breaker didn't need to be open. And hope that you like the talk. Thank you.
thank you.